Welcome to Study Science. Today we're going to be covering predicting chemical equations. Before we get into predicting chemical equations, just know that you are going to need to have a pretty good base of balancing chemical equations before we get into this. But getting into this, there are 5 different types of chemical reactions. For instance, synthesis is your first one. It's just going to be any atom plus any atom equals a molecule. For example, diatomic hydrogen plus diatomic oxygen equals H2O, and that's not balanced. And then there is also the opposite of that, which would be decomposition, and that would just be a molecule that decomposes to 2 different components. For example, hydrogen peroxide will decompose to oxygen and water. And then you have both single and double displacement, and this is just a molecule plus another component will yield a component plus another molecule, and it basically one of the elements of one of the molecules switches over to the other element. So example would be silver nitrate plus copper yields silver plus copper nitrate. And then for a double displacement, this is similar, except it's 2 molecules that yield 2 molecules, but they kind of switch which element is which. So for example, potassium bromide plus silver nitrate yields potassium nitrate plus silver bromide. And then the final type of chemical reaction is a lot less common. It's just combustion of a hydrocarbon. And the main thing you need to know about this is 2 or more molecules that typically have hydrogen, oxygen, and carbon will react to yield water and carbon dioxide. Do remember, before getting into these prediction equations, that you always need to understand how to balance single molecules. So for example, you have copper hydroxide. Now typically hydroxide has a charge of -1, and copper typically has a charge of +2. Just remember that means that copper would need to gain 2 electrons to have just a net charge, and hydroxide would need to lose 1 electron to have a full valence. And remember, when we do balance these, you just want to take the charge and move it each side. So you would end up with, let me get the right pen, copper hydroxide 2. All right, so I have 2 example equations here. So we're just gonna start with aluminum chloride and lead nitrate. So as you can see, the chloride has 3. Now typically that means, because there's not naturally just going to be 3 chloride, that means that aluminum has a charge of +3. And chloride has a just -1 charge. There's also a 2 here, so that means that lead has a +2 charge and nitrate has a negative charge. And then, knowing that this is just a basic double displacement reaction, we're going to switch the aluminum and the lead. So that's going to give us aluminum nitrate 3, because remember that is a +3 charge, and because this is a negative charge, to balance this molecule we need to change this to have 3 nitrates instead of just 2. And then very similar with the lead chloride, it's going to be plus lead Cl2 instead of 3. And then remember, we do need to balance this equation. So to do that, we know there's one aluminum and one aluminum, and we know that there are 3 chloride and 2 chloride, and there are 2 nitrate and 3 nitrate. So how are we going to balance this? Well, we're going to start on this side by changing this to 3 and this, no, wrong way. We're going to change this to 2 and this to 3. So we have the same amount of chloride on both sides. And knowing that, we're going to change this to 2 and this to 3. And that will give us 2 aluminum on each side, 6 chloride on each side, 3 lead on each side, and 6 nitrate on each side. All right, so this equation is very similar. It's going to be another double displacement, so lithium and barium are going to switch. But the first thing we need to do here is distinguish the charges. So if we can see that SO4, the 4 is part of the molecule, so that's not going to be a charge or anything. If we can see that lithium there are 2 lithium, so that usually means that SO4 is going to have a charge of -2, while lithium has a charge of plus. And then on this side, we can see that Ba doesn't have any other, or there's only one Ba. So we can assume that chlorine has a charge of just negative, and barium has a charge of +2. Because we know this is a double displacement reaction, we can just start by switching this to lithium chloride, which is not going to have it's just going to be 1 lithium and 1 chlorine, and then plus a barium sulfate. And what you'll notice about the barium sulfate, if I can, here, I'll just rewrite that better with a different pen. What you'll notice is it's only 1 barium and 1 sulfate. That's because they both have a charge of plus and -2. That means these charges cancel out. It's the same thing as having a fraction that's 2/2 or 3/3 or x/x. It's just 1. So in this case, balancing is a lot more simple. So we know that there are 2 lithiums, 1 sulfate, 1 barium, and 2 chlorides. So all we have to do is give this a coefficient of 2, and then your equation is balanced. All right, so another major part of predicting equations is states of matter. You're gonna need to be able to decipher what state of matter each equation has in its reactants and its products. And that's for things like finding the net ionic equation or finding the total ionic equation. Those are very important later on. So there's 4 main states of matter. There's first solid, and that's just anything that's naturally a solid. So something like a lot of metals, stuff like that. Then you have liquids. Think H2O, hydrogen peroxide, stuff like that. And then you have your gases. And gases are basically just any diatomic gases such as hydrogen, oxygen, carbon, things like that. Not necessarily carbon. And then your last one is a little bit more difficult. It's basically just aqueous. And what aqueous means is something dissolved in another liquid, typically in water. So we're going to touch on solubility rules next, because aqueous plays a massive part in predicting chemical equations.
All right, here are the solubility rules. Just feel free to pause the video or screenshot anything because we're going to need these for the future problems.
I'm just going to finish this video off with one example problem of these predicting chemical equations with the states of matter. So in this case, we have NaCO3, and that's going to be solid, plus MgNO3, and that's going to be aqueous. So if this is aqueous, we want to find out first which part of the molecule is aqueous. And since we know Mg, or magnesium, typically isn't aqueous, we can detect that the NO3 is the part that makes it aqueous. So whatever molecule has the NO3 after this, or in the products, will be aqueous. And then the next thing we want to do, again, is detect the charges of each element. So we know that NO, or Na, it has a positive charge, CO has a negative charge, and because there's two NO3, we know that Mg has a +2 charge. And we know that NO3 has a negative charge. So, and again, because we know this is a double displacement reaction, we can easily know that it's going to be Mg CO3, and then that CO3 is going to be 2 plus NaNO3. Okay, and then how are we going to find out the states of matter? Well, because we know NO3 is typically aqueous, we can say that this is going to be aqueous, and we can say that MgCO3 is going to be solid. Now, finally, we just need to balance this equation. Okay, so since we have one salt on this side, or one sodium on this side, one CO3 on this side, one Mg on this side, and two NO3 on this side, we need to balance the NO3 on this side, so it's going to be 2 NaNO3, and that means that we need 2 NAs, and that will make up for the 2 COs as well. So this equation is fully balanced, and that'll be about it. Thank you for watching this video. Just remember that while these concepts can be very difficult at times, the best way to fully understand them and to learn them is just through practice. So if you're still having trouble with this, just try and practice the equations over and over, and eventually you'll get through it.